We're here today to give you a demonstration on what you get with the electrical tool set when you purchase AutoCAD these days. First of all, what is AutoCAD Electrical? It's a purpose-built software for controls design, and it's used to automate the creation of your schematic and panel drawings. We can also track component information between drawings, and we can also create reports containing this information. So a lot of the manual processes you have to do right now in AutoCAD for controls design, we're going to make life easier on you and automate a lot of those processes. And just like any other tool set, this is truly AutoCAD. It's not a third-party app that sits inside of it or anything like this. It's an Autodesk product built within AutoCAD. If I go to my Home tab up top here, you can see that these are all straight-up AutoCAD tools. Starting at the Project tab, going over to the Conversion Tools tab, these are all dedicated AutoCAD electrical tools. For the most part, when you're in a schematic drawing, you will use specific electrical commands, not AutoCAD commands. And one thing that's going to be different than straight up AutoCAD is what we call the Project Manager, which I have parked on the left, set to auto hide. The Project Manager is where you create your new projects. It's where you add new drawings to a project. It's where you open up projects. So we don't go up to the quick access toolbar like we normally would with AutoCAD and pick the new button for creating a new drawing or the open button to open up an existing drawing. We do that from within the Project Manager. And that's, one aspect that's different than regular AutoCAD is you work with from a project mentality, if you will. Not just one single drawing at a time that's not linked to any other drawings that you might have. So we think at the project level. Now I've got this drawing open right now called Toolset 04. And I'm going to start by creating a simple circuit and show you some of the features that are involved with using AutoCAD Electrical and their, let's say, intelligent symbols. And the first thing I'm going to do is just drop a couple of wires down in my drawing. And then I'll create a simple circuit with some symbols. Out of the box, you get a whole library, multiple libraries of symbols, standard symbols. Your push buttons, your proc switches, your relay coils, your fuses, your circuit breakers, any standard type of symbol we provide in a library out of the box. We also have IEC libraries that you can install. There's a P&ID, there's a pneumatic, there's a hydraulic, several libraries out of the box. That doesn't mean you're not going to still create your own custom symbols / blocks. We encourage you to create your own custom ones. Any blocks that you currently use right now in regular AutoCAD, we can easily convert to an intelligent AutoCAD electrical symbol. And these truly are AutoCAD blocks with attributes. That's what they ultimately are. What makes them intelligent symbols is the symbol naming convention that's involved in the attributes that we need to use to make them intelligent. And we show you how to do all that in class when people purchase the software and take the class, if you will. And when I insert a component, notice that the tag comes in automatically. I have up to 3 lines of descriptions I can add right here. I can type these descriptions in. I could also pick from a list of commonly used phrases, if you will. And we encourage you to add to that list as well. When you insert a symbol, a block, you want to attach a catalog number to it so I can pull up a bill of material at any point during the project, whether, not necessarily the end of a project, but at any time. And when I hit this lookup button right here, it takes me to our parts database. And the parts database, I'm using Access right now. You can use Access or you can use SQL. And one nice feature of the software is you never have to exit the software, let's say, in order to add a new record to the parts database. There's between all the manufacturers and all the different types of components that they provide, there's over like 500,000 entries from all types of manufacturers and all types of components. And you're still going to add to the parts database as well. Even though there's a lot out of the box, you're still going to have catalog numbers that aren't in there. We also show you how to add to the parts database as well. So I'm just going to pick a simple 2-contact relay here. We have what we call installation and location codes. This is another way to manage your project. I refer to these as, different enclosures that you might have in your project. Everything gets wired somewhere. You make that somewhere a location. So as you progress with the project, I might want to run a bill of material on just one particular location instead of the whole project. I might want to run a point-to-point wire report from one specific location to another instead of the whole project as well. Installation codes is just a whole nother layer of management. And notice when I placed the catalog number down that it automatically filled in the terminal/pin information because that's tied to the catalog number itself. Now I'm going to insert a normally closed push button. And it's the same exact insert edit component dialog box as you just saw. Once again, I can type in descriptions. Or I could have picked it from a list of commonly used phrases. Under the catalog data, same thing. I'm going to attach a catalog number to this so it's added to my bill of material. And I'll put a location on there. This time the catalog number didn't dictate the terminal/pin numbers, but that doesn't mean I still can't manually type something in on the fly. And now I'm going to insert a normally open push button. And just to save some time, it's the same exact dialog box that I can fill in with descriptions, catalog data, location. I'll just say okay. And now I'm going to insert what we call a child symbol. When you want to link symbols together, it's called the parent-child relationship inside of AutoCAD Electrical. So if I want to insert a contact off of that relay coil that I just dropped in, the coil is the parent symbol. And now if I drop in the child symbol, notice the tag doesn't come in automatically. I have to tell it who the parent is. I could have multiple relay coils in this project. Well, what contact does this belong to? What is the parent symbol? In this case, it's right in my same view. So I'll just pick it. Anything that I already filled in for the parent symbol automatically gets carried over to the child symbol. So I'll pick OK here. Let me drop down a couple other wires. Like one from here to here. Another one from here to here. And then I'll get rid of the one in the middle here, you're going to notice just a lot of nice drafting features as part of the software as well. I don't have to put tie points down as a separate block as an example. And if I delete a wire that has a tie point connected to it, it'll get rid of that as well. Now, just to finish this circuit off, I'll just throw down a pilot light, if you will. And I'll pick OK here. Now I'm going to go to the next drawing in the project. And I'm going to insert another child symbol. I can pick it under my recently used now. And I'm going to link it right back to the parent symbol that I just dropped down. And once again, it doesn't matter that it's on another drawing, it automatically brings over all the information that I already filled in for the parent symbol. And you can see that it's tied to the parent symbol. Here's the cross-reference 403 right here. This contact is on reference number 503. If I go back to the parent symbol, notice that it's updated immediately. Now, just for the heck of it, I placed a catalog number that was good for a 2-contact relay down. Well, let's say I forget. I'm in design mode. I happen to know I need another contact for that relay. Well, if I try to assign it, this is some of the error checking that's built into the software. It knows that this relay coil is set up for a 2-contact relay via the catalog number. I'm trying to insert a third. When you can catch these types of mistakes at the design level instead of by the time it's out in the field, I'm sure everybody knows that it's a big time and money saver when I can catch these types of errors that I might make at the design level. So I would normally cancel out of here, and then I would go back. I'm not going to do it right now, but I go back to the lookup button and assign it another catalog number that was good for more, in this case, more than 2. It might be 4, it might be 6. Who knows? Now I have no wire numbers in this drawing, with the exception of the hot and neutral. And notice that these come from a different drawing. The question marks will automatically fill in, that is the actual wire number, when I run my automatic wire number command. But the hot and the neutral, basically with the software, you can break a wire and pick it back up somewhere else, and it's constantly going to keep track of one another. So that's something else that you manually don't have to keep track of anymore. So if I go to my wire number command, I can wire number a whole project if I wanted to. I could pick on individual wires, or I could do one drawing at a time. I'll pick drawing wide. And just like that, now I have wire numbers across the drawing. In my wire number format, just like the component tag format, is using the reference number. That's why this is wire number 403. This is why it's 403A. 406 down here, because it's tied to reference number 406, just like all the tags. Now this wire number is 309 because it's coming from a different drawing. If I surf to where this originated, you can see there's the wire number 309, and it's telling me right here, I stopped it here and I'm picking it back up on reference number 402. And if I go back to the destination, there's the 309, and it's coming from reference number 332. So at any point in time, you can break a wire and you can pick it back up somewhere else. Now I'm going to go to my panel drawing, and as part of the same component, I'm going to insert what we call the footprint symbol for that relay that I just dropped down. You have schematic symbols that belong in the schematic. We have footprint symbols that belong in the panel. Footprint symbols is your physical, it's the graphical representation. It's full scale, 1-to-1. So I'm going to go to my panel tab up top, and I'll go to the icon menu for the panel, and I'm going to go to the relays, and you actually insert your footprint symbols via the catalog number. So if I go catalog lookup right here, this is one way that I could insert a footprint symbol. Usually you would use this method if you were inserting the footprint symbol before the schematic symbol. I'm going to go back, and I'm going to pull out a list of all the components that I already have in the schematics. I'll look at all the drawings. Here's every single component that are in the schematics that I need an equivalent footprint symbol for in my panel. Now, obviously, this project has been started, so I'm going to pick this mark existing right here to put an X next to every component that's already been inserted into a panel, and I'll narrow it down even further by picking the hide existing. Well, here's the relay that I just dropped down in the schematic. I'm going to insert this, pre-fill in the rotation of 0. And essentially it knows what footprint symbol to use because the footprint symbol is tied to the catalog number. And notice when I dropped it in, once again, like a child symbol, anything that I filled in on the parent automatically gets transferred to the equivalent footprint symbol. So I can pick OK here. The list comes right back up. I could continue picking from the list and dropping all my footprint symbols into this panel or another one that I might have in the project. I'm going to close this, and the smarts, if you will, behind the panel, the footprint symbols, is they get linked to your schematic symbol, the parent symbol. So if you make a change to the footprint symbol, it automatically updates the schematic symbol and vice versa. So as an example, if I go and edit this, and I'll just edit the description just to make some little change for now. I'll call this relay number 1. And it's going to ask me if I want to update other drawings. You literally see it open up the other drawings. It happens pretty quick, make the change, and then come back here. So now if I go back to the parent symbol or the child symbol for that matter, notice it's been updated here. If I update it at the schematic level, get rid of this again. You're going to notice that it's going to, in turn, update the footprint symbol as well. Now, another change, let's say that I chose the wrong manufacturer, the wrong catalog number for any component. So I'm going to edit this, pick my lookup button, and I'm going to change my search criteria to a square D. And I'm just going to pick a to normally open type X. And I'll say okay here. And it's literally going to swap out the footprint symbol for the square D relay, as you can see right here. It's generally the same size, but obviously every manufacturer, it's going to be slightly different in size, even though it's the same type of component. And as you can see, the square D footprint symbol out of the box has a little bit more detail, in this case, than the Allen Bradley ones. Now, since it's a panel drawing, I can use the regular AutoCAD move command just to move that into place. So this is where they talk about, you know, literally every single drawing in your project is tied together. And when you have components that are tied together in the project, you modify one, the others update automatically. Now we also strive, you know, reusing data. The software really starts to pay for itself when you can reuse data. As an example of reusing data, a couple examples. If I open up this three-phase drawing over here, and let's say I want to copy, you know, this whole circuit right here. So you put it together once. You draw your wires, insert your components like I just did in the previous drawing, and we can draw as many wires as we want at the same time. So when you do have a three-phase drawing like this, each one of these drawings was used using the multiple bus command right here. So I can draw more than one wire at a time. But if you have any common circuits that you use from project to project to project, and a circuit is basically components and wires, a group of components and wires. And first of all, if it's in the drawing, I could say copy circuit. And I'm going to wrap a window around all this stuff. I'll leave the extra contact out of there just to save some time here. And I'll pick a base point, say right at the tie point here, and I'll drag it up to here. And then I'll hit enter. And as you can see, when I copied it, all the tags updated automatically. Wire numbers do not. They reset themselves when you copy a circuit, if you will. But I can always go back to my wire number command right now, pick drawing wide. Takes a second to update the wire numbers. Now, once you have, you know, let's say, okay, I created this circuit once, I'm able to copy it inside this drawing, great. But I want to, you know, either copy it to another drawing, or I use it all the time and I want to save it to a library, a folder. So we can insert what we call W block circuits or saved circuits. If I pick this insert saved circuit command, it brings up an icon menu. So if I select this generic sample user circuit right here, I can place all these components down at the same time. I'm just going to drop it out in the middle of nowhere here. But all the same rules apply if I were to copy it. When you insert it as one. Once it's inserted, it automatically explodes it back to its original entities. It actually, is saved as a block. But as you know, part of the utility, when you do insert it, it explodes it back to its original components and wires, but it also updates the tags all at the same time. That's the power behind it. And as we recommend to people, you know, if you think you're going to reuse a circuit, save it all day long. You can save it to an icon menu where I just pulled that one from. Some people don't like using the icon menu. We can also go to insert W block circuit. So you're saving, you know, the block, the DWG file to a folder, and then you can insert them this way. So if I pick this one, it's similar to the one above it with all the other components on the secondary there. But the main point is, if you have any types of circuits, you can save them as a circuit. You can even build them into a drawing template. So when you start a new drawing, you can have circuits already started. Half your work could be done when you place these into a drawing template to use to create a new drawing. We also have a couple different ways we can insert PLCs. One through what we call a parametric command, and another one is a full unit command. If I insert a parametric one allows me to break the module or add spaces. You can't do that with a normal AutoCAD block. A block is there so you can't modify it for, you know, most instances. That's a good thing. But I'm going to insert just a simple 16-point discrete input module, two different ways. First example is going to be when I insert the whole card. I'm going to change the spacing here to 1. And notice that I have the choice. I could insert all of these or allow for some spacers and breaks. We'll call it rack 1, slot 1. We have some addressing schemes you can pick from. You can add to this list, or you can simply type whatever your addressing scheme is in up here. I'm just going to pick a generic one from the list. So it's just another AutoCAD block with attributes at this point. If I right-click on the block itself and I go back to this edit component command, you know, all the addressing automatically fills in. Again, you could have typed it in, and the rest of them would have followed suit. I've got up to 5 lines of descriptions for each input or output point I could fill in. Most people only use 2 or 3. Notice it has the catalog number already filled in, because when you insert a parametric style, you're inserting it via the catalog number. And then here's some of the other attributes that I filled in as well. So once again, I could type descriptions in. We also have a wired devices option, so you could pick up from the text of a component that you might have going to the input or output, so you don't have to type it in twice. We also have, excuse me, this external file option. If you write your PLC program before you create your drawings, most of the time you can save a text file out of the PLC program of all your descriptions. So you've already typed them in once to the PLC program. We can choose the external file option, so you don't have to type it in twice for each input or output. You could just pick it from a list. We can also go the other direction. If you do your drawings before you write the PLC program, we can save this. We can save a PLC-IO description report. And you can save it to multiple different formats, as you're going to see here in a few minutes when I go over reports. Excuse me. So it's very flexible in that sense. I could save this to a report, pass it on to pass it on to the PLC program. So once again, you wouldn't have to type it in twice. I'm just going to type something in here. Click OK. And there's my IO card. Again, at this point, just another AutoCAD block with attributes. Now I'm going to insert this. I'm just undoing here. But this time, I'm going to choose to break the module. Drop it in again, let's say right here. Change my spacing. This time I'm going to say allow for spacers and breaks. And this is where it's extremely flexible. I can go back to 1. Pick an addressing scheme. And this is why they call it a parametric type of module. You're actually building it on the fly. And it did this before, it just happened pretty quick, but as you can see, it's putting in the individual terminals. In this case, the first one's an input. I could say insert next IO point. Maybe I need a little bit more real estate between the next 2. So I'll put a spacer in there. Then I'll insert a few more. Now maybe I want to show the other half or whatever part of this module either in this same drawing or a different drawing. So I could say break the module now. In this case, I'll put it in the same drawing. And then I'll insert the rest of them. And then I would normally trim this wire right here where I added a space because again, for whatever reason, I might have needed more real estate between these two. And the nice part is sometimes you don't know ahead of time if you're going to need a space between terminals. You might not know ahead of time if you're going to need to break the module. We can definitely handle that after it's inserted into your drawing. I could stretch it, which would allow me to add space between 2 points, or split it, which breaks the module apart. So you can do that after you've inserted one as well. And then we also have full unit PLCs. And these are more, I can't break them, I can't add spaces, but it might be a case where, you want to show a lot of graphics on your card. Parametric ones, not much graphics. A rectangle around a bunch of terminals. Whereas these, the full unit ones, would be for the people that like to show a lot of detail in their module. This, same exact dialog box as before. Again, I could type in the first address, hit enter. The rest of them will follow suit. Whoop. Unless it's a module that has both inputs and outputs, and by the time it got to the outputs, I would have to individually type those addresses in, but everything else is the same. I could type in up to 5 lines of descriptions. I could choose one of the options. Everything else is the same. But again, it's more like a standard AutoCAD block in the sense that I can't break it apart. I can't add spaces. We also have, getting back to the panel, the ability to insert whole terminal strips at the same time. And we do support multi-level terminals. They have a bunch of them already inserted here. But if I go back to my panel tab, and I go to what we call our terminal strip editor. And I'm just going to pick one here, keep it simple. Let's see what this one looks like. In this, which has all the wires on each side of the terminal, you can rearrange those. If you have to supply the people in the field with all the wiring information that's on each side of the terminal. If I pick this layout preview right here and I select update, here's the terminal strip. Also back here, we have the ability to add spares, add accessories. Now you can account for these in your bill of material. And if I go back to the catalog assignment, I can copy catalog numbers if I already have them established and paste them onto other ones. You can assign the catalog numbers from here, or you could have assigned them when you place them in the schematic drawing. So now I'll go back to my layout preview. I'll update it. Now I got a spare on here. And once again, you can include wiring information and a lot of other information, like the size and color of the wire, the component where it's coming from, the location of the component of where, as far as where it lives. Now, for the graphical layout, we usually don't show it because you can probably imagine if I inserted this with all the wiring information into a panel, it'd be difficult to read. And most of the time it might run into, if I put a terminal strip right next to this PLC rack, all that text would just run right into the rack. So usually you insert these from a graphical standpoint. Whoops. Let me get rid of this. From a graphical standpoint, usually you would insert the terminal strip itself. And if you did want to supply the wiring information, you can do that through a table. It's the exact same terminal strip. It's just all the info's in a table. So if you do have to supply wiring information to the people in the field, you place this table, on a new drawing, let's say, that somebody can actually read so you can wire it. And it just created a new drawing for me that I can use. So now if I go back to my project managers, you can see it automatically created a new drawing, put the terminal strip on this drawing in a table format. Now let's talk about reports. And we have, other tools real quick here before I forget. Let me go back here. We have connector tools. We have cable tools. If I want to, let's say, insert a connector, we have a parametric connector that we can use as well. So maybe this is a 18-pin connector. And I'm going to choose at wire crossing here. And it works like the PLC. I could allow for spacers and breaks. I can insert all of them at the same time. I could change the pin setup to 1. And I'm going to pick insert here. So I might come off. Oh, what just happened there? I accidentally hit escape. So let's say as an example, every time you have a PLC, you immediately take it to a connector. Now I can drop the whole connector down and have it adjust to the spacing of the wire. And it's just another AutoCAD block with attributes at this point. And then I had it adjust to the spacing. So every single time it sees a wire, you put it in there. I didn't have to do that. And after you do place a connector down, we have a whole bunch of edit features, because again, you might need to split this. You might need to add pins. Maybe you didn't pick the correct amount. We can also create cables. We have a cable marker. It's just another symbol. So maybe you're coming off the other end of this with a cable. I can assign it, let's say, a catalog number. So here's a, let's say, 25 conductor cable. I'm not going to insert all of these. And when I do, it automatically knows what the color code is going to be because it's built into the catalog number. If it was a homemade cable, I wouldn't assign a catalog number. I'd give it my own, and then I can pick from a generic list of color codes. This list can be added to very easily as well. But I pick OK, and it's just going to ask me to continue to insert more children, let's say. And again, it knows what the color code is for each child based off of the catalog number. And I'm going to stop here. And now we can pull out cable reports. And the cable reports can be used to actually wire. It's a cable from to report. So you should be able to hand that to anybody and they should be able to wire to it. We can also, with the electrical tool set in AutoCAD Electrical, I'm not going to get into too much detail on this right now, but if anybody's using Inventor, we can literally link the two softwares together, and it's a dynamic link. It's not just a handshake. I could take this cable information, pass it on to my Inventor colleague who's designing a 3D model of it and routing it in a 3D format, showing every single conductor that's coming out of one end to another, coming out of one end of the cable to the component that it's going to. You can even pull out nail boards from within inside of Inventor. So we can use cables for that as well. Now let me talk about reports. Any data that is in your drawings inside of a project, you can pull out a report on because there's so many available fields for each category. So if I go to my reports, and we have both schematic reports and we have panel reports, just like with the drawings. They don't separate them, but they're two different categories. We've got bill of material reports. We've got wire from to reports, component and connector. PLC, I just talked about the PLC IO address and descriptions. Terminal reports. Some people don't like to get into that type of detail that I just showed you in the drawing, so they'll represent the terminals through a couple of reports. Connector reports, cable reports. We even have a wire from to, or a wire label report. So just as an example, Let's say I go to from to, and I'll set it for the whole project. I'll process all my drawings. And if I want a complete point-to-point wire report for the whole project, I would combine all locations. And this will account for every single wire number that's in my project. And missing wire numbers, as you can see up here. Every report, you can change the format of. And this is one of my favorite features of the software. I've used competitive ones. You know, we all do some things better than others. I love the report generation inside of AutoCAD Electrical just because it's very straightforward on how to change your format. When I say change your format, I'm showing the wire number, the location of the component, where it's coming from, the pin number of the component, and then where it's going to, the location, the component, and the pin number, and I'm showing the size and color of the wire. If I pick change report format, I can move these fields around. These are all the available fields that I can add to it. And this is what I meant by, if there's something that you want to report on that's in your drawings, you'll be able to do that. So as an example, maybe I want to see sheet numbers here. So after pin 1, I'll tie in SH1. In pin 2, I'll tie in SH2. I'm done. I don't have to exit the software. I don't have to go to some separate database, try to create queries and fields and tie them together. And I stay right within the software and I'm done. Now, also, you can take any report and you can save it to a file or put it onto a drawing. If I pick save to file, I can save it to any one of these 5 popular formats: a simple ASCII text file, an Excel spreadsheet, an Access database, even an XML format or comma separated or delimited. Excel is a pretty popular one. I would simply point it to the location of where I want it to go. In this case, I'll save it to the folder that I'm using for this particular project. I could name it anything I want. It gives it a default name. Save it. You could even incorporate a script into this. I'll say close, no script. And now, if I go to Windows Explorer, here's the spreadsheet that it just created. You can open that up, do anything you want to it. And that's what I meant by, well, before I go there, if you don't want to do a whole project, and this is why we have these location codes. Maybe I want to see just the wires that go from the MCAB 5 to the operator station. Maybe I'm farming the operator station out to a panel shop. Here's a from to point-to-point wire report for just those 2 locations. I talked about the PLCIO utility. Here's the PLCIO descriptions, not utility, but report. If you created your drawings first, save the address and descriptions, pull that into your PLC program so you don't have to retype all the descriptions you already put into the drawing. So again, you could save this to a file. You can see that there aren't many descriptions filled in here. There's some. But once again, I could save this maybe to a text file, bring it into your PLC program, and not have to type it in twice. If I go back to my panel drawing, I'm going to run a panel report, and I'll choose a bill of material just for the drawing. I'll pick OK. Here's a bill of material for just this drawing. Once again, all the same rules apply, and I use this example in class all the time. You know, everybody's bill of material is different. Yeah. We all have a description, a manufacturer, a catalog number, but the order of them and maybe if, you know, different types of fields to report on, everybody's different. So you go to change report format, set it up exactly how you might be creating a bill of material now, and you're done once again. But the real point here is you can also put any report onto a drawing. I could have it automatically get placed in a certain area. AutoCAD, or AutoCAD Electrical, I should say, uses AutoCAD tables when you place a report back onto a drawing. And we have some different styles to choose from, and you can create your own custom tables and add them to that list very easily. I'll pick OK here. You know, this would probably go to a different drawing since this one's pretty crowded, but I can drop my bill of material right back onto a drawing as well. And again, this can be configured any way you want. So you can take any report, save it to a file, or place it directly back onto a drawing. Nameplates is another popular report. If I go back to my panel reports and I pick nameplate, and I'll say active drawing again, missing a few tag names here, but the point is, what a lot of people will do with this is save it to a file and then take that file to your engraving machine. And you're done. If you don't do your own engraving, you can pass the file along to the vendor who's doing it. And one more point, I'll make something similar. We can take the wire label report. This will account for every single wire number that's in the project. I can save this to a file, and then you can take, you know, whatever, if you're using a Brady printer or whatever manufacturer, most of them nowadays will accept a file, save it to the file, take it to your printing machine for your wire labels, and you're done. No more having to go through the drawing manually, figure out what the wire labels are that you need printed out. You run one report and you're done. And it will account for every single instance that it's using the same wire number on your column or on your commons as well. So this is an intro to what you get with the AutoCAD Electrical Toolset. A little bit more powerful than straight up AutoCAD. And again, hopefully one thing you got out of this, that imagine the time savings, you know, once you get up and running with the software, with all the automatically cross-referencing, the reports, the automatic wire numbers, save you a ton of time versus just using straight up AutoCAD for controls drawings. Any questions out there? I don't see any going right now.
I don't either. Good job.
Well, thank you. Ashley, you want to send it off from here?
Sure. Well, thank you for the presentation and thank you all for attending. If you do think of questions later on, you can simply reply to that confirmation or reminder email you received from GoToWebinar. We can get those questions to Greg or your sales rep to get them answered. Once again, a short survey will pop up as we close down. And also a reminder that you will receive an email tomorrow, which will contain a link for the recording that you can watch again. It does look like there's one question that
Yes.
popped in.
Let me answer that real quick. I'm glad somebody, he or she, asked it, because I didn't even talk about title blocks. So real quick here. The answer to the question, yes, it does take over for your sheet set manager. And we have a title block utility in the software where you can update every single title block you can update the title block across a whole project. So as an example, if I go to the project here and I go to descriptions, this is our Hagerman title block as an example. And you can incorporate your own title block that you're currently using right now. You can use the same block with all the same attributes that you're using right now. But if I make a change to this anywhere, like instead of this saying overhead cylinder, I'll call it machine face. And I have more attributes in here that I could change as well. And I'll pick OK. And then I would go to the title block update command. And in this case, instead of trying to figure out what I did change, I'll just say select all, go project wide, process all my drawings, and it does it completely in the background. I'm done. So now that says machine face right there. If I go back to, let's say, this drawing right here, as you can see, this has been updated as well. Every single drawing in the project title block wise has been updated. So, yep, it does take over your sheet set manager, and we have the tools to update the title block across the whole project. So like Ashley said, if anybody else has any more questions, make sure you let us know and we will get back to you. Okay.
All right. Well, have a great day, everyone.
Yep. Thank you, everyone.